multiplying algebraic indices. So that means we're looking at terms that might look like that. They have algebraic terms, so like an x, so it could be any number, and it has a power, it has a function working above it there. Sorry, an indice, not a function. And what we're looking to do is, say we have a to the power of 3, and what we want to do is multiply it by another variable with a power as well, but this time they're just bases of the same variable, so the same letter. We could also just as easily do something like 2 squared times 2 to the power of 4, because they have the same base, but we're not worried about them today, just these ones, because it's going to be the same rule anyway. If we expanded this out, a to the power of 3 would be a times a times a, and then if we expanded this a squared out, it would be a times a. So we can see here we've now got 5 a's, so a to the power of 5, because they are multiplied all together. They're not plussing or not adding, they're multiplying all together. So a times a times a times a times a is a to the power of 5. And if we have a look, we can start to see a bit of a pattern. If we do a couple more of these, we started off with 3 and 2, and what I would say is that you can see where we got that 5 from, and we can make a guess later on, because what we've actually done is say that if we have a base, let's use a base x with a power a, just a random one, and we multiply it by another term with the same base, a base x, and this time it's got a b for a power, what we actually get is x to the power of a plus b. Now we can see up here in this example we actually ended up with an answer that was 3 plus 2, so we found that. So if this is our rule here, we can apply that really easily. So instead of having to expand it out every time, I could give you one that said a to the power of 4 times a to the power of 19. Now I don't want to write out a times a all the way to the 19 times, but I know with this rule I can say that this will be, we've got the same base, so I can say it will be a to the power of 4 plus 19. And a to the power of 4 plus 19 is a to the power of 23. So it's quite a big number, but we've been able to do it very quickly with our rule. Now we can do the same thing if we have, for example, numbers working this time. So let's go 4x squared times 6x to the power of 4. We know that this x squared means x times x, and we know that this means x times x times So we could expand it out. So let's go with that. We could say 4 times x times x times 6 times x times x times x times x. So we've got all of those, but I don't want to keep expanding them out every time. That's why we use this rule. Let's look at all our x's. How many x's do we have here? If we did our rule, we'd have the 2 plus the 4, so we should have 6. 1, 2, 3, 4, 5, 6, so we do. So we're going to have a term of x to the power of 6, but we've also got these numbers to work with. And sometimes we forget that the numbers are the easiest part. We're just doing 4 times 6, which is 24. So if we did that one again, we could say 2x squared times 4x to the power of 3. We have to work with our numbers first, so that would be 2 times 4, and then we would have our x variable, so to be x to the power of 2, remember it's plus 3, so 2 times 4 is 8, and x to the power of 2 plus 3 is x to the power of 5. So we have to keep coming back to this rule. If we are multiplying, there's a times sign, and we've got bases that are the same, we can just add the powers together.